So greeting YouTube, beautiful mind here. Let's see. So we're going to continue. We're continuing chapter 2, our discussion on exponential and log functions in our calculus for business course. Uh-oh. Okay, maybe. Okay, I think we're okay. And so some objectives here. We want to differentiate exponential base e functions. Let me see. Is this lagging? Nope. We want to differentiate exponential base e functions, and we want to solve applied problems involving exponential base e functions and their derivatives. Okay. Keep in mind for our discussions, the derivative is going to be the instantaneous, is a slope, or derivative is the slope of the tangent line at a point, which is the instantaneous rate of change at a specific value. Okay. So the derivative of the function f of x equals e to the x is itself, right? That's a property of e, the function e. I think a mathematician was working derivatives, and that limit definition, I think it was like the limit as n goes to infinity of 1 plus 1 over n to the power of n. I think that's how it went. But a mathematician noticed that, the derivative of this function was itself, and so that's why it gets its own thing, like this. So f prime of x equals f of x, or the derivative of e to the x is itself, right? So that's just a property of exponential. Okay. So like if we look at the exponential function, and like whenever we look at the slope of the tangent line at any given value of x, it's going to produce itself back. So let's just kind of walk through these. We're asked to find the derivative of the following. So then for a, dy by dx is going to be 3, just basically itself, 3e to the x. Even if you use the product rule, I mean, I think you can just say the constant times the derivative, right? And derivative of e to the x is itself, so that's it there. For b, so then for b, our dy by dx, okay, we need to use the product rule here. So the first, which is this guy, the derivative of the second is this guy, plus the second, which is this guy, times the derivative of the first is going to be 2x, right? We could factor out that e to the x from both of them. Let's just factor. So this is going to be the same as e to the x times x squared plus 2x. Okay, I'm not sure how they want the result to be presented, but we can do this. It might either be the above line or this line. One of these two should be there. And then c, we could use quotient rule, or we can rewrite that x cubed as x to the negative 3. Let's just do the quotient rule. So low d high minus high d low over low low. So the bottom, which is this guy, times the derivative of the top, which is this, minus the top, which is this, times the derivative of the bottom is going to be 3x squared all over low low. So the bottom squared is going to be what? 3 times 2 is 6. Right? Let's see, we can factor out an x squared from both terms. We can factor out x squared times e to the x from both terms on top. So we'll factor out x squared e to the x, and what we're going to be left with, we're going to have an x there, and minus 3 over x to the 6, but then this square turns this 6 into a 4. So then ultimately we get e to the x minus 3 over x to the 4. X to the 4. Let's try that again. X to the 4. I'm kind of run out of space, so that's what's going on there. Paste. Like this. This is fine. Okay. We got 3e to the x for the first one. You see it here. We got e to the x squared plus 2x. Okay, and then e to the x times x minus 3 over x to the 4. E to the x minus 3, x to the 4. How's sons? Huh. Anyway, I'm going to let that be. Oh, and just a quick check. I'm going to leave this as an exercise for you. Okay, I'm going to leave this for you. So if you wanted to get additional practice. All right, so then this one is saying instead of having e to the x, suppose we had e to some function, right? So this is really just an application of the chain rule. So then this derivative, again, is basically the derivative of the outside function times the derivative of the inside function. So if we apply the property of the derivative of e to the x, it's going to be itself times the derivative of the inside function. Okay? So the derivative of e to the u is going to be itself times the derivative of the inside function. The derivative of e to some power is the product of e to that power and the derivative of that power. Okay? So then in this example, for part A, dy by dx is going to be itself e to the 8x times the derivative of the power is just going to be 8. So let's do this. Just going to rearrange it. Ultimately, we'll get 8 times e to the 8x. Okay. And then for B, dy by dx. So it's going to be itself e to the negative x squared plus 4x minus 7 times the derivative of the power. So that's going to be negative 2x plus 4. Okay, I'm going to leave that one. Okay, I just kind of want to rearrange these so that we can be clear about what's going on. So we're basically saying that polynomial times e to that power. Okay, put this here. So I just rearranged it so it could be clear, you know, as far as the notation. And then part C, our dy by dx, it's going to be itself. So it's going to be this. Okay, times the derivative exponent. Okay, so that derivative is going to be, we got to use the chain rule a couple of times, all right? So then the 1/2 comes down, x squared minus 3 to the power of a negative 1/2 times 2x, okay? So then ultimately we get, I'm going to just kind of rearrange everything. We get 2x e to the square root of x squared minus 3 over 2 times the square root of x squared minus 3. Wait a minute. Oh yeah, because that's an exponent. We can cancel out the 2's, so I'm just gonna kind of erase them just because I'm out of space. But those 2's should cancel, and I think this is it. Okay, let me see. All right, 8e to the 8x, 8e to the 8x. And again, I just rearranged it. I put the e on the other side, so that's fine because we're using the commutative property of multiplication. Negative 2x plus 4. And then we get this x times e to the x e to that power over the power. Okay. That was an adventure a little bit. Let me see my time. We should have plenty of time. We're doing pretty good. Let's keep it moving. I'm going to leave this as an exercise for you. Find the second derivative, right? So higher order derivatives. So basically, take the derivative and you take it again. In this case, we're going to take it a total of 2 times. Okay, let's start with what was given. We have this y equals e. Can I make this like full screen? Okay, e to the negative 5x squared, right? So then dy by dx exponent, let's see, it's going to be itself, e to the negative 5x squared times the derivative of the power is going to be what? Negative 10x. Okay, I think that's it there. Okay. Oh, that's not the final though, because we're doing second derivative. So then the second derivative of y with respect to x. So it looks like we have to use the product rule. So that's going to be the first, which is this, times the derivative of the second, which is going to be negative 10. So the first times the derivative of the second plus the second, which is this negative 10x, times the derivative of the first. The derivative of the first is going to be itself times the derivative of the power. Okay. It looks like both terms have negative 10. Okay, let's factor out what's common. So it looks like we could factor out negative 10 e to the negative 5x squared, and what's going to be left over, let me highlight what I took out so it's clear. I took out this guy and this one. I'm going to highlight it in orange, right? So that's what I took out. Oh, actually, I also took out this. I'm going to do this one in blue and this. So the orange and the blue, they both had the orange and the blue, so that's what I took out. Okay, first times the second, yeah. So then what's left over, from that first term, it looks like 1 is left over. The second one looks like it's minus 10x squared. The blue is gone. Okay. All right, let's go with that. Paste. I'm trying to just block this. I'm going to resize this one. Okay. Okay. So let's see. Let's compare it to what they get. Using the chain rule. Okay, they did that first. That's the second derivative. 10. Let me see. So we can distribute that negative. It should be 10x squared minus 1. Yeah, that's fine. We got the same thing. Like if I distribute the negative, it'll be what they have. So it's essentially the same thing. It's just a different articulation, but it's the same. Okay, let me see my time. So Frankel's Fishing Emporium invested $50,000 in an account that earns 1.25% annual interest, compounded continuously. The value of the account after 2 years is given by this. Find A of 5 and A prime of 5 and interpret their meanings. Okay. A of 5 looks like we can just plug in, right? So that's going to be the future amount after 5 years. So then A of 5, 50,000. E to the 0.0125 times 5. Okay, we just need our calculator there. So that's going to tell us the future amount after 5 years. Okay, so just going to do 50, 1, 2, 3, times e to the power of 0.0125 times 5. It should be something bigger than 50,000. So it should be approximately $53,224.72. Okay. A prime. Okay, so for A prime. So first we need to take the derivative. Okay. So then A prime of t, that's going to be 50,000. So the derivative of e is itself. So that's going to be e to the power of 0.0125 t. And then we're going to say times the derivative of the exponent is just going to be 0.0125. Kind of running out of space here. So then A prime of 5, we basically plug in a 5 into that formula that we just found. Okay. I'm just going to kind of write the result that I get. So I'm going to just recall what I have because it's all there. The 5 is still there, but then I need to say times 0.0125. Okay. Let's do 5. So in 5 years, the account is going to have that 53,000. Here, let me write this one. Here we get, I think it's $665.31. Let's see. Here. Here. And let's just see what's going on. So the future amount is at $53,224.72. And then 665, right? So after 5 years, the value of Frankel's Fishing Emporium is that 53,224.72. At that instant, the value is growing at a rate of $665.31 per year. So that's the instantaneous rate of growth. Okay. I think that's it there. And then we have a section summary. The main thing here is that the derivative of e is itself. Okay, and then this is like the chain rule. The derivative of e to some function is itself times the derivative of that function. And that's the main thing. We got done a little bit early with this section, which is okay. Okay. So main thing with my course is just be sure that you're getting your assignments in, submit it promptly, and I'm available. Just you have to reach out to me. If I don't respond to your email, just ask me during class time. Okay. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.